The slide rule, the pocket supercomputer that built our world. Look at this, an icon of engineering. Nearly 2 miles of steel and cable, suspended hundreds of feet above the churning Pacific. It has endured earthquakes, gale-force winds, and the weight of 1 billion cars. We built these things. We built cities that scraped the sky. We built machines that carried us to the moon. We tamed rivers and connected continents. And every single one of these triumphs required millions of calculations. Stress loads, fuel consumption, material tolerances, wind shear, an endless river of numbers. So here's the question that should stop you in your tracks. How did they do it all without this? Without a single microchip, without a single line of code, without a battery? They did it with this. This is a slide rule, a pocket-sized analog computer made of wood, plastic, and glass. It has no memory, it has no screen, and for over 300 years, it was the most powerful computational tool on the planet. This simple stick of numbers designed our modern world, and then, in the blink of an eye, it vanished completely. Our world runs on digital computation. It's so deeply embedded in our lives, we don't even see it anymore. Every email, every transaction, every design is a storm of ones and zeros managed by processors doing billions of calculations per second. But it wasn't always this way. Step back just 60 years. The office workflow that defined the 20th century was entirely physical. Information wasn't sent, it was carried. Voice memos weren't MP3s. They were recordings etched into wax cylinders, then magnetized onto tape, then squeezed onto mini cassettes. And a manager didn't type their own letters. They dictated them to a secretary. A highly trained professional who would transcribe, type, and correct everything by hand. This entire ecosystem of skills and tools, the very rhythm of the workplace, is now completely alien to us. It was a manual mode of existence. The same was true for engineers. Before cloud servers and CAD software, if an engineer needed a complex calculation done, they didn't have a computer on their desk. The computer was often a person or a whole room of people who would crunch numbers all day long. But in 1614, a Scottish mathematician named John Napier gave the world a brilliant shortcut. He discovered logarithms. The math is a little dense, but the concept is revolutionary. Logarithms are a clever trick that turns the difficult problem of multiplication into the much easier problem of addition, and it turns division into simple subtraction. A few years later, an English minister named William Oughtred had the genius idea to etch these logarithmic scales onto 2 pieces of wood that could slide past each other. And just like that, the slide rule was born. Here's how it works. You have the main body, called the stock. You have the middle piece that moves, called the slide. And you have this little window with a hairline, called the cursor. Each scale is a logarithmic number line. To multiply 2 by 3, you find the 2 on the main scale. You slide the middle scale so its 1 lines up with that 2. Then you look along the slide to 3, and right below it on the main scale is your answer, 6. You physically added the lengths that represent these numbers. You have performed multiplication by sliding a piece of wood. And it didn't stop there. Soon these rules were covered in dozens of scales. Scales for square roots, cube roots, trigonometry, exponents. It became a dense, cryptic library of mathematical relationships. To an outsider, it was hieroglyphics. But to an engineer, it was a finely tuned instrument. For the next 300 years, this was the tool that built the modern age. Every skyscraper, every dam, every airplane designed before 1975 started its life on a slide rule. Think about the Empire State Building. Construction began in 1930. The engineers had to calculate the load on every single one of its 200,000 tons of steel. A single mistake could have been catastrophic. Their only tool? A 10-inch slide rule. Beautiful, almost magical part of it all. The slide rule didn't just give you an answer, it gave you a feel for the numbers, it gave you intuition. When you use a calculator, you type 2,345 times 8.1, and you get an answer, 19,002.5. The number just appears. You trust it, but you don't necessarily understand it. On a slide rule, you physically move the scale representing 2,345. You can see its relationship to the numbers around it. As you slide it to multiply by 8.1, you can watch the answer get bigger in a smooth analog way. You can see how a small change in one variable affects the outcome. Engineers called this keeping a sense of the decimal. The slide rule was only precise to about 3 significant digits. It was up to you, the operator, to know if the answer was 19 or 19,000 or 0.019. It forced you to understand the problem on a fundamental level. It kept you honest. Nowhere was this blend of human intuition and analog computation more critical than here. The Apollo program. The race to the moon. The Saturn V rocket was, and still is, the most powerful machine ever built. It was a 36-story controlled explosion. Guiding it required constant, complex calculations for trajectory, fuel burn, and orbital mechanics. The onboard computers had less processing power than a modern singing birthday card. The real heavy lifting, the cross-checking, the what-if scenarios, that was done by thousands of engineers on the ground with these. The Pickett N600ES was the slide rule of choice for the Apollo missions. It was made of lightweight aluminum, and yes, it went to the moon. Buzz Aldrin had one with him in the Eagle lunar module. Imagine the pressure. A multi-billion-dollar mission, the lives of 3 astronauts on the line, and the final check on a critical burn calculation comes down to a person, their brain, and a stick of precisely marked metal in their hands. The slide rule wasn't just a tool, it was an extension of the engineer's mind. It was fast, it was reliable, and it never, ever ran out of batteries. And they were beautiful objects, crafted from mahogany, bamboo, and later, high-quality plastics. The markings weren't printed, they were engraved with painstaking precision. Using one felt like using a fine instrument. There was a tactile satisfaction, a connection between mind and material that we've lost in our age of glass screens and tapping fingers. It was the desire to not just find the answer, but to understand its shape. And then in 1972, this happened. The Hewlett-Packard HP-35, the world's first scientific pocket calculator. It could do everything a slide rule could do and more. It gave answers with 10 digits of precision, instantly, and it had a glowing red digital display. It was magic. The end was not gradual, it was an extinction-level event. It's been called the Great Slide Rule Massacre. Within 18 months of the HP-35's debut, the entire industry, an industry that had stood for 3 centuries, was wiped out. Kufel and Esser, the legendary American manufacturer, had been making the finest slide rules in the world for over 100 years. They were the standard. In 1975, they quietly ceased production and buried their master manufacturing plates in a landfill, a final, definitive act. Professors who had taught slide rule courses for decades walked into class one day, dramatically dropped their personal rules into the trash, and announced the future had arrived. Students sold their prized slide rules back to the bookstore for pennies on the dollar to buy a calculator. An entire body of knowledge, an entire way of thinking and problem-solving, became obsolete in a single generation. Just like the secretarial pool that vanished with the word processor, the world of the analog engineer was gone. So why should we care? Why remember this forgotten tool in an age where a supercomputer lives in our pocket? Because the story of the slide rule is a reminder. It's a reminder that the tools we use shape the way we think. The engineers of the slide rule era were forced to have a deep, intuitive understanding of their calculations. They had to estimate, to approximate, to feel the numbers. They worked in a world without an undo button. This tool represents an entire philosophy, a manual mode of thinking. It's a testament to the incredible things humans can achieve, not just with raw processing power, but with ingenuity, intuition, and a deep connection to the work of their hands. If you enjoyed this look into the analog past, please consider subscribing to Manual Mode. We explore the forgotten tools and lost skills that shaped our world. Click the bell so you don't miss our next story. But don't just watch. Do something. Go on eBay or to a local antique shop. You can find a perfectly good slide rule for the price of a couple of coffees. Buy one, hold it, try a simple multiplication. Feel what it's like to see the math happen in your hands. There's a richness there that a screen can't replicate. This is Manual Mode, and finally a question for you. What tools do we rely on today that are so essential we can't imagine life without them, but might vanish just as quickly as the slide rule? Let me know your thoughts in the comments below. Thanks for watching.